GATE 2018 Civil Engineering Set 1 Question 22. A 1:50 model of a spillway is to be tested in the laboratory. The discharge in the prototype spillway is 1000 m³ per second. The corresponding discharge to be maintained in the model, neglecting variation in acceleration due to gravity, is. The answer needs to be found up to 2 decimal places. The relevant NPTEL reference has been cited. For model testing in engineering, the concept of similarity is used. There are different kinds of concepts that are used. The first one is geometric similarity. In this, we compare the length scale of the model and the prototype. For kinematic similarity, we compare the length scale and the time scale. For dynamic similarity, length, time as well as force scale are compared of the model and the prototype. Another concept that is used in some applications is thermal similarity. In kinematic similarity, Froude's number for the model should be same as the Froude's number for the prototype. For the model and prototype to be consistent, in the question we have been given the ratio of model to prototype as 1:50, and the discharge in the prototype is given as 1000 m³ per second. As we saw, the Froude's number for model should be equal to the Froude's number for the prototype as per kinematic similarity. As per this, we would get V by GL for the model equals V by root over GL for the prototype. Taking V on one side, we would get Vm by Vp equals square root of Lm by Lp. It was given in the question that there is no difference in the gravitational acceleration. This is our first equation. Next, we need to compare the discharges. So Qm by Qp would be equal to the area of the model into the velocity of flow in the model divided by area of the prototype into velocity of flow in the prototype. This can be further written as Lm over Lp whole square, which is essentially the area term, into Vm over Vp. This can be further written as Lm over Lp whole square into Vm over Vp, that can be written as square root of Lm over Lp from equation 1. This would give Qm by Qp equals Lm over Lp raised to the power 2.5. Taking Qp on one side, to obtain the value of model discharge, we would get Qm equals Qp, that is 1000, into Lm over Lp, that is given as 1 by 50 raised to the power 2.5. This would give the value around 0.056 m³ per second. Since the question instructs us to round it off to 2 decimal places, we can round it off to 0.06 m³ per second. So the corresponding discharge which needs to be maintained in the model for a prototype discharge of 1000 m³ per second and length ratio of 1:50 was found out as 0.06. The relevant NPTEL reference has been cited.